Well, hello everyone. In this lesson, we will be talking about the quadratic formula. The quadratic formula is the formula for finding the x-intercepts of a quadratic function. The quadratic formula is x equals negative b plus or minus square root quantity b squared minus 4ac over 2a. This may be used to find the x-intercept, or what we call the roots of a quadratic formula, a quadratic equation, in the form ax squared plus bx plus c equals 0. Now let's look at an example. Find the roots of 5x squared plus 9x plus 2 equals 0. So what we want to do, it is already in the form ax squared plus bx plus c. We want to identify our a, b, and c here. A is equal to 5, b is equal to 9, and c is equal to 2. Now, let us recall our quadratic formula. X equals negative b plus or minus quantity b squared minus 4ac all over 2a. Now let us plug in our numbers for a, b, and c, and this will give us negative 9 plus or minus square root 9 squared minus 4 times 5 times 2 all over 2 times 5. And if we work that out, we have negative 9 plus or minus square root 81 minus 40 over 10, and still simplifying that a little bit more, we have negative 9 plus or minus root 41 over 10. Now notice here we have two roots. The first one is x equals negative 9 plus root 41 over 10, and the other root is x equals negative 9 minus root 41 over 10. And that is where your quadratic graph would intersect your x-axis in these two places. Now let us talk about a special thing called a discriminant. The discriminant is the quantity that's underneath the square root sign in the quadratic formula, and that part is b squared minus 4ac. This can be used to find the number of real roots of a quadratic equation. There are three scenarios. The first one is if b squared minus 4ac is greater than 0, then there are two real roots. The second scenario is if b squared minus 4ac equals 0, then there is one real root. And the third scenario is if b squared minus 4ac is less than 0, then there are no real roots. Reason, if the quantity under the square root sign is negative, then there's no real number that fits that. The square root of a negative number is not real. Okay, so let's look at a couple of problems with this. Determine whether each of the following quadratic functions has no real roots, one real root, or two real roots. Let's look at a situation with 2x squared plus 2x plus 7 equals 0. What do we have there? If we're going to use b squared minus 4ac, and so for the 2x squared plus 2x plus 7, a would be equal to 2, b would be equal to 2, and c would be equal to 7. Now, b squared minus 4ac would be equal to 2 squared minus 4 times 2 times 7. And that would be 4 minus a bigger number, 56, That gives negative 52. So this number is less than 0, so no real roots. Right? No real roots. Then for the next one, x squared plus 4x plus 4x squared plus 4x plus 4, our a will be equal to 1, right? B equals 4, and C equals 4. So then b squared minus 4ac, b squared minus 4ac equals 4 squared minus 4 times 1 times 4, right? And that would be equal to 16. Minus 16 equals 0. Now 0 is equal to 0, so there is one real root. So there is one real root. One real root. Right? One real root. All right? And so let's look at the final one. Right, C, that is 7x squared plus 6x, 7x squared plus 6x. And what is happening there is that A is equal to 7 and B is equal to 6. But C, there's no C, so C equals 0. C equals 0. Now our b squared minus 4ac, b squared minus 4ac will be 6 squared minus 4 times 7 times 0. So that would be 36 minus 0 equals 36, and 36 is greater than 0. So there are two real roots, right? Two real roots. So you're checking our discriminants. If b squared minus 4ac, in this case 36 greater than 0, it's two real roots. If it's equal to 0, one real root. It's less than 0, no real roots. All right? So let's look at an application of quadratic functions. Application of quadratic functions. A rectangular plot of land has a length of y units and a width of x units. A length of y units and a width of x units. The perimeter of the land is 100 meters. Okay, the perimeter of the land is 100 meters. What is the maximum area of the land? So let us look at this. Sketch a diagram. Sketch a diagram. Okay. Let's call this x and y. All right. And so perimeter would be 2x plus 2y. And also told that perimeter is equal to 100. So therefore equation can be 2x plus 2y equals 100. Right, so we know that 2x plus 2y equals 100. We want to solve for one of these variables. Let's say solve for y. We want to have 2y is equal to 100 minus 2x. So y will be equal to 50 minus x. All right, 50 minus x, or 100 minus 2x over 2. All right. Now, we want to find the maximum area. How do we find area? Area is equal to x times y by formula. Area is equal to x times y, and we already found that y was 50 minus x, so that's x times 50 minus x. So then that will be 50x minus x squared. Now, in order to find where this is maximum, this is a quadratic right here. This is a quadratic. So you want to find the maximum of a quadratic. Find the maximum of a quadratic function. So the max occurs at the vertex where x equals negative b over 2a. So max at the vertex where x is equal to negative b over 2a. So where is your a and b? Your a is right here and your B is right there. So A here is equal to -1 and B will be equal to 50. So let's plug these in. X equals negative B over 2A. That's going to be -50 over 2 times -1. And so that will be 25. So X equals 25. And then what is our Y? Our Y is equal to 50 minus X. And that is going to be equal to 25. So the maximum area, then, one way you can look at it is A is equal to X times Y, which is equal to 25 times 25. That would be equal to 625 meter squared. Or alternatively, you could have done X times 50 minus X, which could have given you the same thing. A was equal to X times 50 minus X. If you didn't want to go ahead and solve for the Y, and that would be just the 25, again, times 50 minus 25, and it would still get 625 meters squared. So either way, your maximum area is 625 meters squared. All right, so that is your final answer for the maximum solution, or the maximum area of this piece of land. Thank you very much. Don't forget to subscribe and like, and see you in the next lesson. Thank you.